Hello everyone and welcome to our channel, Moo Tekie. A special welcome to all the dairy technologists and students tuning in. This is class 4 in our dairy engineering series, where we continue our discussion on plant sanitation by diving deep into the installation, care and maintenance of pipes and fittings. This unit on sanitation is a core part of dairy engineering. The process of installation begins with the very design of the building itself. It requires a systematic approach to the layout. It is crucial to ensure there is adequate space for all activities. The design should also create minimal intrusion into the operator's workspace. And finally, due consideration must be given to the construction, operation and maintenance factors for every single piece of equipment involved. Moving on, we will see a key planning tool. This is the piping and instrument diagram, or PID for short. A PID shows the complete arrangement of all the process equipment, the piping, the instruments, the valves, and all other fittings. It is the essential map for the entire system. Now let's look at the specific steps involved in the installation process. Step 1 is that all process equipment must be identified by a unique equipment number. This equipment should be drawn on the plan roughly in proportion, showing its correct location. Step 2 is that all pipes must be identified by a line number. The pipe size and the material it is made from should also be shown. Step 3 is that all valves, including both control and block valves, must be shown with an identification number and their size. Next, we explore the remaining installation steps. Step 4 includes all ancillary fittings that are part of the piping system. This includes items like inline strainers and steam traps, and each must have its own identification number. Step 5 is that all pumps must be identified by a suitable code number. And step 6 is that all control loops and instruments must be included on the diagram with their own identification number. Now let's talk about the sizing of pipelines. Getting the size right is critical. Oversizing a pipe increases the installation costs unnecessarily. Conversely, undersizing a pipe increases the pressure drop in the system, which is inefficient. It is important to know that the terms pipe and tube are different. Pipe size is referred to by its nominal bore, while tube size is specified by its actual inside diameter. One golden rule is that the size of the suction pipe of a pump should never be smaller than that of its discharge pipe. An important aspect of the system is the pipe fittings themselves. These are the components that connect sections of pipe together. The methods used to make these connections are vital. The three primary methods are flanged connections, welded fittings, and threaded couplings. The choice of connections is an important aspect for hygiene. Connections must first and foremost be effective. They must be easy for cleaning and sterilization. They should not have any cavities or dead ends that cannot be cleaned properly. Specifically, any pockets caused by branches in the pipelines should not be deeper than 6 times the pipe's diameter. There is a strong preference for welding pipes and fittings using an inert gas process, as this reduces the number of pipe unions. This minimizes potential crevice areas, which are notoriously difficult to clean. And as far as it is feasible, fittings should be avoided close to the suction side of a pump. Another critical component are the pipe valves. These devices control the flow within the system. Some traditional valve shapes, like gate and globe valves, have complex internal passages. These shapes render them very difficult to clean, making them potential sources of contamination. The modern alternative involves a choice between ball valves, butterfly valves, or diaphragm valves. The ball valve is frequently favored for several reasons. Its valve stem is isolated from the fluid, preventing a path for contamination. It has a simple quarter-turn operation for easy opening and closing, and it is perfectly suitable for CIP, or clean-in-place cleaning. Valves can be classified based on their role in the system. Block valves are used to prevent any unwanted flow past a given point in a pipe system. They are essentially an on-off switch. Throttling or control valves are used to control either the rate of flow or the pressure of the flowing medium. They allow for precise adjustment. Beyond standard pipes and valves, there are special pipe fittings that serve specific purposes. These include measuring devices for quantifying flow, thermocouples for measuring temperature, and pressure gauges for monitoring system pressure. Other special fittings are sight glasses for visual inspection, pipe supports for holding the system in place, and sampling devices for taking product samples. A sight glass is a very common special fitting. There are different types used for different jobs. A level gauge is used to see how much liquid is in a tank. A sight flow indicator allows an operator to watch the fluid moving through the pipe. A circular sight glass is a simple window into the pipe. And a fused sight glass is a more robust version, often able to handle higher pressures. Sampling devices are another crucial special fitting. They need to be installed at strategic points throughout the plant to collect product samples for quality analysis. Their design must preclude any risk of contamination from outside the pipe, ensuring the sample is pure. Now let's discuss pipe supports. Pipes must be firmly supported to prevent sagging and stress. However, they should not be so rigidly restrained that natural movement is prevented, as this can cause damage. The tubing should be supported at regular intervals to keep it straight. Extra supports are needed near valves and at all changes in direction. The materials used for hanger components and floor stand supports should be made of stainless steel. This avoids external corrosion and prevents galvanic action, which can occur between dissimilar metals. Rubber insert pads may be used to isolate the tubing from its support. This helps to reduce vibration and noise. Finally, rigid anchoring should often be replaced by floating supports. These flexible supports avoid distortion of the entire tubing system due to expansion and contraction from temperature changes. The required spacing between supports depends on the pipe size. For a 50 mm pipe, the maximum distance between supports is 2.4 meters. For a 75 mm pipe, it is 3.4 meters. For a 100 mm pipe, the distance is 4 meters. And for a 125 mm pipe, supports can be spaced 4.5 meters apart. This brings us to the vital topic of maintenance. The first maintenance point is that worn-out gaskets in pipeline joints should be replaced periodically. This replacement should happen before they become brittle, deformed, or lose their shape permanently, as damaged gaskets can cause leaks. During a preventive maintenance inspection, look for distress cracks on walls and footings near the pipe anchors. These cracks will indicate an improper layout that has not properly accounted for thermal expansion. Also check all the supports of the pipelines. Ensure they are still firm and have not been dislodged from their installed positions. Another key check is for vibrations. Ensure that vibrations and expansions caused by process equipment, like homogenizers and pasteurizers, are prevented from being carried on to the pipelines connected to them. You must also check if any recent plant modifications, like an expansion or shifting of equipment, have affected the pipeline installation. All pipes must remain properly supported and connected without any new stresses. Any damage to the insulation on a pipe must be repaired immediately. This is not only to prevent excessive heat exchange with the surrounding air, which wastes energy, but also to prevent rapid outer corrosion of the pipe underneath. Lastly, all accessible points of friction on the piping system components, especially on valves, should be frequently lubricated. This keeps them operating smoothly and prevents them from seizing. Thank you for joining us for this detailed look at piping systems in a dairy plant. Remember, a well-designed, properly installed and meticulously maintained network of pipes is the lifeline of any dairy operation, ensuring efficiency and the highest standards of product quality and safety. We hope this was helpful. Author, Moo Tekie. Thank you. See you in the next class.